The late Devonian was a time of profound change. The supercontinent of Gondwana stretched across the southern hemisphere, its vast landscapes teeming with primitive plants and early terrestrial animals. Fern-like trees reached for the skies, and the first forests began to take root. The air was thick with the scent of fresh vegetation, and a chorus of ancient insects filled the atmosphere. In what would one day become southeastern Australia, a dramatic tectonic collision left its mark on the land in the many faults created and in the mineral riches it deposited. To the west of the Walhalla goldfields, we have a zone known as a back arc basin. This back arc basin hosted many supervolcanic eruptions during the late Devonian, but the Cerro caldera was the largest, and that's what we'll be discussing in this video. Remember to check out the OzGeographic's website to see the article for this video. The link to that will be down in the comments and the description below. Let's get into it. Without warning, the ground trembled. Gentle rumbles quickly escalated into violent shakes, causing ancient trees to sway and creatures to flee in panic. The sky darkened as a massive plume of ash and smoke began to rise, casting a foreboding shadow over the land. The Cerro caldera, a monstrous supervolcano, had awakened. With a deafening roar, it unleashed its fury upon the world. Molten lava burst forth, flowing like fiery, debris-laden rivers, incinerating everything in its path. The once blue sky turned a menacing shade of grey as ash and pyroclastic flows blanketed the landscape. The very air became scorching, making it nearly impossible to breathe. This was no ordinary eruption. The Cerro caldera, being a subaerial caldera, erupted above water, its cataclysmic power evident in the vast columns of ash that reached for the heavens and the rivers of lava that reshaped the land. For days the eruption continued, its relentless energy transforming the serene Devonian landscape into a hellscape of fire and ash. This eruption overlaps with the timing of the Devonian extinction event, and one can't help but wonder what role the Cerro caldera played. When the fury of the Cerro caldera finally subsided, the world that emerged was unrecognisable. The lush forests of the Devonian were buried beneath volcanic rock and ash. The once clear rivers were choked with sediment, and the sky, which had been darkened for days, slowly began to clear, revealing a sun that cast a muted reddish glow. The Cerro caldera's original size, before erosion, was an impressive 27 kilometres or 17 miles in diameter. The eruptions took place along the edge, leading to an accumulation of volcanic rocks on the caldera's floor. As the volcano's activity persisted and its magma chamber depleted, the caldera progressively lowered. When this supervolcano experienced a caldera collapse, the land itself became fractured, forming ring dikes, circular faults that we see in the largest of volcanic eruptions. But nature, in its infinite resilience, began the slow process of healing. Over time, rains washed away the ash, and the first signs of life began to emerge from the scorched earth. Ferns and mosses, hardy pioneers, colonised the barren landscape, paving the way for more complex plants and animals. The Cerro caldera, now silent, stood as a testament to the Earth's raw power. Its vast expanse, a scar on the land, would serve as a reminder of the day the world changed forever. But from this cataclysmic event, new opportunities arose. As the millennia passed, the memories of the eruption faded, but the legacy of the Cerro caldera lived on. The land, once ravaged by fire and ash, was reborn, its beauty and diversity a testament to the enduring spirit of life. Thanks for watching. Cerro Galan is a supervolcano located in South America. A supervolcano sounds kinda cringe, but it is what the name suggests. A major earth-shattering volcanic eruption. These eruptions are so large and so powerful that they affect the entire planet. They dramatically alter the climate of the Earth after an eruption occurs, plunging it into a harrowing, long-winded volcanic winter that's spurred on by the release of an unthinkable amount of material and solar-reflecting aerosols that go on to linger in the stratosphere for several years or possibly even decades after the eruption. The duration of their stay is dependent on just how large an eruption is. And along with the release of these aerosols is the release of vast and unimaginable quantities of volcanic ash that work to shroud the sun, preventing even the tiniest glare from penetrating through the thickest parts of the hazy ash-filled clouds that darken the Earth everywhere they drift. As a result, plants die, plankton dies, ecosystems collapse. mass death and starvation occurs, and you get the idea, it's a pretty shit time to be alive. But like always, life persists. In today's episode, we're going to cover the supervolcanic complex known as Cerro Galan. This episode was created for, and the topic of it was suggested by Tark, our first level 3 Patreon member. If you'd like for me to make a video specifically for you, like I have for Tark, consider signing up to our Patreon or YouTube channel. So let's travel to the northwestern region of the Catamarca province in Argentina, to take a look at one of the many supervolcanoes that dot our planet. Welcome to OzGeographics. Cerro Galan is a 35 by 20 kilometer wide caldera. The last eruption released enough material to be classified as a magnitude 8 on the Volcanic Explosivity Index, which is, at this point in time, the highest classification reserved for the largest volcanic eruptions to have ever occurred on our planet. Cerro Galan is one of the many volcanoes that dot the vast Andean mountain range. This volcanism, and the nearby subduction zone, has deposited vast mineral wealth in this part of South America, and it's known for having one of the largest copper porphyry deposits to exist on our planet. The Incans were known for amassing a ridiculous amount of gold, and at its height, the Incans were the most gold-rich empire of the time, making its rulers extremely rich. And, well, where there's a lot of gold, you can bet there's a Spanish man trying to get it. And they were victims of the very belligerent Spanish Empire, who treated them, well, very, very shit to say the least. But in the good old days, before churros arrived to the Americas, the Incans wouldn't have had to look far to find gold. Large pieces would have been found en masse pretty much everywhere. Most streams would be auriferous to some extent, and gold would have more than likely been visible by the naked eye, with much of it existing at a size that could literally be plucked out of the gravels by hand. This area is still a bit of an enigma. The Andes is a hard place to study, and an even harder place to properly read. We have so much that's going on here, from the nearby tectonic collision and subduction event that has occurred, and the many volcanoes and volcanic eruptions that have exploded and released lava flows all along this mountain range, making it even harder to read. We have to figure out which flow came from where, how old it is, the differences between the layers, how many layers there are, and there's always a chance of getting two similarly looking tuff layers confused. This area is very interesting geologically speaking, obviously, but the formation and the ramping up of explosivity of Cerro Galan is what really strikes me. You see, Cerro Galan is the largest post-Miocene caldera so far identified in the Andes. It developed on an area that was saturated with metamorphic rocks, and these rocks were already high in silica prior to being further injected with silica-rich hydrothermal fluids, which contained the many precious metals, including the aforementioned gold and silver. Prior to the generation of Cerro Galan, the creation of a Horst and Graben topography formed. These structures, also referred to as block mountains, are notorious conduits for magma to rise through, due to the massive weaknesses that are created during the uplift and depression type pattern that we see in these types of topographies. These Horst and Graben events occur when the land is pulled apart, and this is a running theme for the generation of subduction-related supervolcanoes. From Lake Toba to New Zealand's Taupo, these are all sitting on areas where there is a pronounced stretch in the land. So the area where Cerro Galan is located is essentially a rift zone, and it's normally in rifting events that we find the Horst and Graben topography occurring. Now, this might sound strange to people that are somewhat familiar with the basic effects generated by a subduction event, which is known for the high levels of compression generated, as two plates are literally butting heads as they push against each other, driven by an unimaginable amount of pushing force behind both of them, and eventually, if there's an oceanic plate, it will subduct and begin to be pushed down, deep into the earth ever more. Mountain building events, also known as orogenies, occur as a result of the compressive stress generated by these events. But after this zone of compressive stress, we normally have an area where the crust actually stretches, called a back arc basin. It's complicated to explain and not really worth the time, but essentially in this little area of stretch, we normally have the generation of supervolcanoes. The thick, viscous, felsic magma is able to take advantage of this massive weakness in the crust to ascend and pull in bathylitic magma chambers. Now, at this point, you might be getting an idea of where I'm going with this. Volcanism originally started here around 15 million years ago. Several andesite and dacite composite volcanoes formed and erupted before a new stage of a more violent and explosive volcanism would commence. The Cerro Galan complex developed along two north to south fault lines that were about 20 kilometers apart. Dacitic to rhydacitic magma utilized these fault lines to ascend, leading to at least 9 major ignimbrite eruptions occurring in a period of between 4 to 7 million years ago. For those who don't know, ignimbrite is the rock left over after a pyroclastic flow, which is arguably the most dangerous element of supervolcanic eruptions. These layers show us that 9 separate, very explosive events occurred that generated and released superheated pyroclastic flows, which travelled pretty far before finally accumulating in place and cooling, forming the rock known as ignimbrite. Whilst pronounced, these volcanic eruptions would be dwarfed by what was to come. It sat quietly for 2 to 3 million years, building up its magma reserves in the vast and batholith-sized magma chamber that exists beneath the Earth, and then it woke up. In one single eruption, around 2 million years ago, Cerro Galan roared back to life, releasing a magnitude 8 eruption, which would go on to release the Cerro Galan ignimbrite layer. And it was during this eruption that the major caldera collapse occurred, forming the massive structure that exists today, which is a frightening reminder of the power that was once released here in the not too distant past. During this eruption, Cerro Galan turned up the heat on the pyroclastic flows, pun intended, releasing a truly tremendous amount of partially molten material, bearing areas in between 30 to 200 meters worth of ignimbrite, some of which was highly welded, meaning these fellas were still very, very hot when they were laid down, which tells us that this event and the pyroclastic flow all pretty much happened at once. As previously mentioned, we have many, many metamorphic rocks that exist in the bedrock here, all of which pretty much fuel Cerro Galan. Massive waves of basaltic magma are intruding beneath the cracks formed by the weaknesses here, and they're melting this silica-rich bedrock on a grand scale. So this begs the question, is Cerro Galan still active? To which I would reply, yeah, most likely. Guess we'll find out in the next million years, hey? Thanks for watching. Nestled amidst the serene landscapes of Wyoming lies a tale of nature's raw power waiting to be told. Yellowstone's tranquil geysers and pristine beauty conceal a tumultuous past. Approximately 640,000 years ago, this peaceful land was the epicenter of a cataclysmic event known as the Lava Creek super eruption. This event forever reshaped North America. While today's Yellowstone captivates visitors with its geothermal wonders and its vast wilderness, its geological narrative is a story of 3 colossal eruptions. However, it's the Lava Creek eruption that arguably stands out the most in this trilogy of geological fury. To grasp its sheer magnitude, one must envision an explosion 2,500 times more potent than the 1980 eruption of Mount St. Helens. Earning its title of megacolossal, this eruption spewed a staggering 1,000 cubic kilometers of volcanic material, or 239 cubic miles, its ash even finding its way down to the Gulf of Mexico. One of the most enduring remnants of the Lava Creek eruption is the tough layer it released. This layer of consolidated volcanic ash, transitioning from hues of pink to muted greys, paints a vivid narrative of the eruption's scale and reach. Composed predominantly of rhyolite, it speaks of magma so viscous that its explosive release was nothing short of monumental. The eruption's aftermath was marked by layers of ash and the formation of the Yellowstone caldera, a vast depression measuring approximately 30 by 45 miles or 48 to 72 kilometers wide. This crater-like structure stands as a testament to the eruption's immense power resulting from the ground's collapse when the magma chamber emptied. Beyond its geological impact, the eruption's ecological footprint was profound. Immediate surroundings were transformed by pyroclastic flows and thick ash deposits. On a global scale, the eruption introduced what might be termed a volcanic winter, with volcanic ash and gases permeating the atmosphere, leading to cooler global temperatures and disrupted ecosystems. Nature, however, is tenacious. In the aftermath of such devastation, the region witnessed the emergence of resurgent domes, a testament to the continued influence of subterranean magma. Rhyolite lava flows signalled Yellowstone's enduring volcanic spirit, reminding us that this region remains geologically active. From the perspective of early humans, this eruption would have reshaped their entire world. As landscapes transformed and resources became scarce, adaptability became their lifeline, a testament to the resilience of life in the face of nature's fury. In the modern era, Yellowstone attracts millions with its beauty, but it also garners the vigilant gaze of scientists. Equipped with cutting-edge technology, they monitor the region's every tremor and geyser eruption, ensuring we're prepared for any potential future geological events. As we reflect on the Lava Creek eruption, we're reminded of our planet's dynamic nature and the tales embedded within its very fabric. Such events emphasize the delicate balance of nature and the awe-inspiring, often humbling narratives waiting to be discovered. Our exploration of Earth's chronicles is far from over, and, as always, there are more stories waiting just beneath the surface. Thanks for watching. Nestled in the heart of North America, stretching across Wyoming, Montana, and Idaho, Yellowstone National Park is more than just a haven for wildlife and nature enthusiasts. It's a living testament to Earth's tumultuous geological past and the resilience of nature. But beyond its scenic beauty and geothermal wonders, there's a deeper narrative, one that intertwines cataclysmic eruptions, hidden mineral treasures, and the enduring spirit of preservation. Long before it became a cherished national park, the Yellowstone region was a hotspot of geological activity. Beneath its serene landscapes, the Yellowstone hotspot, fueled by a molten plume of magma rising from deep within the Earth's mantle, was silently brewing. As the North American plate drifted over this hotspot, magma chambers swelled, setting the stage for numerous eruptions that would reshape the continent. Around 2.1 million years ago, the ground beneath Yellowstone led to the Huckleberry Ridge eruption. This wasn't a short-lived spectacle, but a multi-phase event that spanned decades or more. Out of the 3 recent eruptions unleashed here, this eruption was the most powerful. It released more than double the amount of material than the supervolcanic eruption that we covered in yesterday's video, when we looked at Yellowstone's most recent super eruption. Link to that in the description. In today's video, we'll take a look at Yellowstone's Huckleberry Ridge super eruption. It's often said that Yellowstone has had 3 supervolcanic eruptions. This isn't true, only 2 have taken place here. Instead, the truth is that 3 caldera-forming eruptions have taken place here. Yesterday, we covered the super eruption that released 1,000 cubic kilometers or 240 cubic miles of volcanic material. Today's super eruption released more than double that. In the middle of the 2 though, another small eruption was strong enough to produce a caldera known as the Mesa Falls eruption. It only released an estimated 280 cubic kilometers or 67 cubic miles worth of tephra. If this went off today, we'd notice its effects in places far and wide. But the word only is used sparingly here, as this is powerful enough to affect the climate of the entire planet. If this went off today, we'd notice its effects in places far and wide. But back to the big one. The initial outburst unleashed pyroclastic flows that scorched vast territories. As the eruption evolved, the Huckleberry Ridge tephra, a vast expanse of volcanic ash and debris, was propelled into the stratosphere, eventually settling over a significant portion of what is now the United States. This ash layer, still evident in geological formations, is a silent reminder of the eruption's magnitude. The climax of this volcanic event birthed the original Yellowstone caldera, a depression that captures the essence of the park's volatile past. This occurred when the magma chamber became unstable after much of it was released during the eruption, leading to a significant collapse as the earth above filled the void. In the immediate aftermath, the region resembled an alien landscape, with an entirely new topography. But nature, in its timeless way, embarked on a journey of healing and transformation. The nutrient-rich volcanic soil breathed life back into the land, paving the way for the thriving ecosystems we witness today. In the present day, it's challenging to work out the shape and size of the original caldera as it's been changed by subsequent eruptions. But geologists have painstakingly worked to map the area out, and we have a pretty clear picture today. The caldera from this eruption is referred to as the Island Park caldera. 2,450 cubic kilometers or 590 cubic miles of material is thought to have been unleashed during this event, making it one of the largest known eruptions in the Yellowstone hotspot's history. The volcanic winter would have been a harrowing event to have lived through, lasting for years to decades in length, due to just how much solar-reflecting aerosols were pumped into the stratosphere by the ash plume, only for it to be spread planet-wide by the trade winds. But Yellowstone's story isn't just about its volcanic roots. The park is a treasure trove of minerals. From the rhyolite and obsidian formations that hint at its fiery past, to the geothermal display of sulfur-laden fumaroles and the cascading travertine terraces of mammoth hot springs, Yellowstone is a geologist's dream. Recognizing the region's unparalleled geological and ecological significance, the US government, in a visionary move in 1872, declared Yellowstone a national park, and it was the first of its kind planet-wide. Now, this wasn't merely a nod to its beauty, but a commitment to protect the peace of the Earth's dynamic history. With this designation, pursuits like mining, which once eyed the park's mineral wealth, were halted, ensuring that Yellowstone's legacy remained undisturbed. I personally am against this. I mean, this park's gonna blow up one day. You might as well get what riches you can now, but it is what it is. Today, as visitors wander through Yellowstone with its predictable geysers and diverse habitats, they're walking through pages of Earth's geological diary. The park stands as a symbol of nature's might, its ability to rejuvenate, and our collective responsibility to preserve its wonders. So the next time you find yourself marveling at Yellowstone's beauty, remember you're witnessing a tale of volcanic fury, nature's resilience, and a commitment to conservation that spans generations. Thanks for watching. The roads around the Yellowstone National Park are somewhat unsurprisingly melting. I say unsurprisingly because at this site, underneath the ground, lies a basaltic magma chamber that's released wave after wave of supervolcanic scale eruptions, with some of the largest volcanic eruptions ever released on Earth being associated with this magmatic hotspot. And yep, as a result of the many effects that this magma chamber has on the surrounding land, one of them is a melting of the roads, and that's what this video is all about. The hotspot responsible for the Yellowstone supervolcano had originally been located underneath the Pacific Ocean, but as the North American tectonic plate drifted further and further west, it eventually passed over this magmatic hotspot, sparking a wave of supervolcanic eruptions that would consist of dozens upon dozens of calderas existing in present day, dotted from the southwest and slowly moving all the way to where the Yellowstone hotspot is located in present day. It would reshape the land dramatically each time these supervolcano eruption events occurred, leaving behind massive calderas in present day. These supervolcanic eruptions were so frequent they overlap each other, making the ability to count them all almost impossible because there are so many that have taken place. The most recent and youngest supervolcanic eruption is the one that is underneath Yellowstone National Park in present day, and this is where our story begins. As most people know, Yellowstone has a remarkable amount of hydrothermal activity that is taking place in present day. Water that was released by past rains slowly seeps into the ground until it reaches the bedrock underlying Yellowstone, where it then becomes superheated by Yellowstone's basaltic magma chamber. When this happens, the hot water rises back to the surface, unimpeded due to the open plumbing system that exists here, with the highly fractured ground allowing vast amounts of water to circulate around, due to the shattered nature of it from past supervolcanic eruptions that occurred here. Convection currents circulate the hot water so it never gets hot enough to flash to steam and to trigger a phreatic volcanic eruption. But what does this have to do with the roads at Yellowstone? Well, everything. Yellowstone's land is basically the worst place on Earth to lay asphalt. Let me be clear and just firstly state that the roads melting has nothing to do with Yellowstone supposedly erupting soon. This isn't some doomsday sign, it's just a reality of the land here, much like shifting land and earthquakes are in other countries. The phenomenon occurring here is called asphalt deflection, and it's been known to occur here for decades. It basically means the ground here rejects asphalt. The abundant hydrothermal activity makes the surrounding ground pretty damn hot, and laying asphalt directly onto a hot surface like this is a recipe for damage to occur, especially during summer, when the thin strip of asphalt that is the road would essentially be baked from beneath by the hydrothermal water and from above by the hot sun, turning it into a semi-fluidic, rubbery consistency. If the road heats up substantially, the asphalt loses its solid consistency and actually begins to flow more like silly putty.
This can lead to it sticking onto car tyres, and the road itself twists, warps, and loses shape. Potholes form along with ripples, and the road becomes unusable whilst hot. So, if you're thinking of going to Yellowstone, maybe go there in the winter months, unless you want a memento from your visit there to be in the form of asphalt-laden tyres.